Assalamu alaikum everyone. Welcome to another video at O Levels Pro. Today we are going to start a whole new section of chemistry, of O Levels chemistry, and that is organic chemistry. It's very important, needless to say that it's very important section of O Levels chemistry, and it is equally easy as well. You just need to get the basic concepts right, and you'll be able to absolutely cream through organic chemistry, inshallah. Again, what is organic chemistry? It is the study of compounds of carbon. It is the study of compounds of carbon. It's the study of compounds of carbon except for carbonates. Except for carbonates. Carbonates are not organic compounds, okay? So it is a study of it is a study of compounds of carbon except for all the carbonates. Potassium carbonate, sodium carbonate, they are not organic compounds, okay? Now, since all the organic compounds will have at least one carbon atom, it means we know that carbon does not form ionic bond and it does not form metallic bond. It has to form covalent bonds. This is why all organic compounds are actually covalently bonded. All organic compounds are covalently bonded. Okay. Now the thing is that all organic compounds are divided into different groups, and these groups are called homologous series. They are called homologous series. For the series that we are going to study in O levels chemistry are alkanes. There are alkenes. We'll be studying alcohols and carboxylic acids. Mainly, we are going to study these four groups of compounds, okay? Carboxylic acids. Now, homologous series, each homologous series have unique properties, as in all the elements in a particular homologous series have the following properties. Okay. Now, number one property is that they have same chemical properties. All the compounds in a particular homologous series will have the same chemical properties. For example, if we're talking about alkanes, then all the alkanes will have the same chemical properties. They often ask you about the characteristic of homologous series. So remember these few characteristics. They have same chemical properties, but their physical properties change. Their physical properties change down the series, like boiling point, for example, right? Boiling points increase down the series. As you go down the series, as going down the series means the molecules are getting bigger. So when molecules are getting bigger, boiling points increase. Okay, boiling points increase as molecules get bigger. Molecules get bigger down the series. Okay. Third one is very simple. They have the same general formula. You will be familiarized with general formula just in a while. So just remember that they have same general formula. Okay, all the alkanes follow the same general formula. All the alkenes follow the same general formula. And fourth one is that they have same functional group. They have the same functional group. What is a functional group? Functional group is atom or group of atoms, or just maybe a double bond, or just bonds. Repeating again, they have the same functional group. What is a functional group? Functional group is an atom or group of atoms which defines the function of a homologous series. All the homologous series will have a unique functional group. Alkanes do not really have a functional group, they just have carbon-carbon single bonds. Alkenes have a functional group carbon-carbon double bond. Alcohols have the functional group OH, and carboxylic has the functional group COOH. Okay, we are going to study each of them one by one, so don't fret over it if you don't understand it. Just remember these four characteristics of homologous series. Now starting with alkanes. Now let's start with alkanes. We have alkanes. Right. So, uh, first thing you need to know about the stems as well. Okay. You need to know about the stem. What is the stem? Stem is the main carbon chain. For example, number of carbon atoms, and what they are called. Okay, the stem, and then what are they called? Okay, so when there is only one carbon atom, the organic compounds names start with meth. When there are two carbon atoms, organic compounds name starts with eth. When there are three carbon atoms, organic compounds name start with prop. When there are four, it's but. When there are five, it's pent. When it's six, it's hex. When it's seven, it's hept. Okay. When it's eight, it's oct. When it's nine, it's non. Okay. And when it's 10, the 10 carbon atoms, the name of the compound will start from dec. Okay. So meth, eth, prop, but. You just need, for O level, you just need to remember meth, eth, prop, but. It would be convenient for you if you remember all of these, because you're going to study them in A levels anyway, and there were some questions that will have carbon atoms more than there will be some questions in which there will be molecules with more than 4 carbon atoms. There will be pent, there will be hex, there will be hec, there will oct. So it's better that you remember all of these. Okay. Moving on to alkanes. Alkanes. Its general formula is CnH2n plus 2, where n is number of carbon atoms. N is number of carbon atoms. Okay, so we are going to write the molecular formula, okay, and the name and the structural formula. Okay, structural formula. Okay, so when n is equal to 1, plug n is equal to 1, you'll have C1, H2 multiplied by 1, 2, plus 2, 4. So it will be CH4. Its name would be meth. Since it's one carbon atom, it will start with meth. And all alkanes have the same suffix ane. All the alkanes have the suffix ane. So it would be methane. Okay. And its structural formula would be C, H, H, H and H. Okay. If n is equal to 2, put n is equal to 2, C2, H2, 2 is 4 plus 2, 6. So formula becomes C2H6. And the name of the compound would be ethane. How do you write it? C2H6. So each carbon atom will have to form 4 bonds. So 1, 2, 3, 4. You'll have to make sure all the carbon atoms have 4 bonds. So 1, 2, 3 and 4. That would be ethane. If n is equal to 3, it would be C3H8. It would be called propane. How is it C3H8? You plug in n is equal to 3, C3H. 2 3s are 6 plus 2, 8. If you see, number of hydrogens is twice the number of carbon atoms plus 2. Twice the number of carbon atoms plus 2. Okay, now you have propane, 3 carbon atoms. Okay, 3 carbon atoms, and just make sure that all the carbons make 4 bonds. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. It would be propane. Okay. Moving on, n is equal to 4. N is equal to 4 is but. Formula would be C4H10. It would be butane. and the structural formula would be C, 4 carbon atoms, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, uh, you have to attach all the hydrogens. Very tedious to do, but you'll have to do it. Okay. So n is equal to 5 would be pentane, n is equal to 6 would be hexane, then heptane, then octane, then nonane, and then decane. Okay, so that's how you write the molecular formulas and the structural formula of alkanes. Now we are going to write their properties. We are going to study about their properties. Okay, first let's talk about the fact that they are called saturated hydrocarbons. They are called saturated hydrocarbons. You are going to study two hydrocarbons. Okay, first of all, you are going to study two hydrocarbons in O levels. There are alkanes and then there are alkenes. They both are hydrocarbons. What does hydrocarbon mean? It means that a compound that contains only hydrogen and carbons. Hydrocarbons are compounds which contain only carbons and hydrogens. So alkanes and alkenes are the two hydrocarbons that you're going to study in O levels. Among those hydrocarbons, alkanes are saturated hydrocarbons. Why are they called saturated? Because they do not have space. They do not have any space, to let anything into their structure. For example, if you see, all the carbon atoms are fully occupied. All the 4 bonds are fully occupied. There is no free bond. It means that you cannot add anything into it, which is why they are not very reactive. If you want to, they only undergo reactions in which one thing can be substituted with another thing, because they do not have a space to add another thing. But what they can do is replace hydrogen with other things. Okay, so they are going to have very few reactions. Okay, one is called combustion, which is mandatory for all the organic compounds. Okay, combustion, there is going to be combustion. There is going to be something called substitution or free radical substitution. Okay, so the third one is it's not exactly a reaction, but let's say it's called cracking. Okay, let's talk about combustion first. Combustion is burning of anything actually in the presence of oxygen. We have studied it before as well. Okay, there are two types of combustion. There is complete combustion. Then there is incomplete combustion. So complete combustion happens in excess air, which means excess O2. And incomplete combustion happens in limited supply of air, limited O2. So how do both of these reactions play along? Let's take methane. So methane will react with oxygen to form carbon dioxide and water. All the organic compounds that you're going to study, all of the organic compounds that you're going to study having combustion reactions, they are going to produce carbon dioxide and water. So whenever you are about to write a combustion reaction for a hydrocarbon or for any organic compounds, remember that particular organic compound will just react with oxygen to form carbon dioxide and water. The balancing is going to be different for everyone. So there are 1 carbon, 4 hydrogens. So 4 hydrogens, 2 plus 2, 4 oxygens. So 4 oxygens. You can take ethane, C2H, 6, reacted with oxygen to form again carbon dioxide and water. Okay, so carbon 2 on the left, 2 on the right. Okay, and hydrogens are 2 on the right, 3 on the left, are multiplied by 3. So oxygen became 4 plus 3, 7 on the right. So you'll multiply it by 7 by 2. You can react any alkane with oxygen, it will form carbon dioxide and water. Let's take nonane. Nonane is 9 carbon atoms. So what would be its formula? C9, and hydrogen will be twice that of carbon atoms plus 2. So 18 plus 2 would be C9H20. It will react with oxygen to form again carbon dioxide and water. Okay, the 9 carbons, hydrogens are 20 hydrogens. How many oxygen? 9 2s are 18, 18 plus 10, 28, so you multiply it by 14. So that is complete combustion. In incomplete combustion, carbon dioxide is not formed. Instead, carbon monoxide and Carbon monoxide is formed, and soot as well. Soot is pure carbon. Carbon monoxide is formed, which is extremely toxic. Okay, so if they ask you what is the disadvantage of incomplete combustion, you will say that carbon monoxide is released, which is a toxic gas. Okay, so that was the first reaction, combustion. Let's talk about another reaction, another of their properties. Okay, the other one is called substitution. Substitution is pretty simple. You are substituting one thing for another. Substitutions often happens in footballs. In football matches, you must have seen that one player is substituted for another. It's pretty much like that. One hydrogen is substituted by a halogen. For example, methane reacts with chlorine to form in the presence of UV light. And what will be formed? CH3Cl. CH3Cl plus HCl. How does that happen? Let's discuss that. We have CH4. So you have CH4 which reacted with chlorine. What would happen here? Chlorine will take the place of hydrogen and hydrogen will take the place of chlorine. So they got substituted. Okay, chlorine took the place of hydrogen and hydrogen took the place of chlorine. As a result, you got Cl came over here and it became CH3Cl. I wrote it like this here, and HCl. Okay, so that's what happens. But this reaction doesn't stop here. This is only the first step. This reaction will keep on happening until all the hydrogens are substituted, because chlorine is in excess. Now CH3Cl is formed in the second step. Now the CH3Cl will react with more chlorine and another hydrogen will be replaced and substituted for chlorine. So hydrogen was removed and chlorine was added. CH2Cl2 plus HCl. In the third step, now the CH2Cl2 that was formed in the previous step would react with chlorine further and will form, again, one hydrogen will be substituted for chlorine. So you will reduce one hydrogen and increase one chlorine. So CHCl3 plus HCl. In the fourth reaction, CHCl3 will again react with chlorine. Again, chlorine will substitute hydrogen, so that will result in removal of one hydrogen and addition of one chlorine, which will result in CCl4. This reaction will end here because there is no more hydrogen to substitute. This reaction is called substitution reaction. This particular compound is called carbon tetrachloride. Okay, it is used as a solvent. It's called carbon tetrachloride. Okay, now remember, the number of hydrogens that are present in an alkane means that the same number of HCl will be formed. If, for example, the reaction is happening with chlorine, okay, so number of hydrogens is directly proportional to number of HCl formed, because because these hydrogens are going to decide number of steps or number of rounds substitution is going to take, and in every round HCl will be produced. For example, if they ask you that C2H6 is reacting with HCl, if they ask you C2H6, which is ethane, is reacting with chlorine, how many HCl will be formed? You will say 6. Why? Because there are 6 hydrogens which will be replaced with 6 chlorines, and hydrogen will take place of chlorine and HCl will be formed in every round. So in total there will be 6 moles of HCl formed. Okay, so that was substitution. Now let's talk about a very important property that is called isomerism. Isomerism or isomers. Isomers are the molecules that show isomerism. Okay, isomerism happens when a molecule have the same molecular formula, but different structural formula. but things may not seem as things may not be as they seem. For example, let's say if I talk about butane, so C. Okay, I can also, we know that butane is C4H10. Butane is C4H10. I can also write it like this: CH3, CH2, CH2, and CH3. How? Because if you draw its structure, let's draw its displayed formula: CCC, HHH, HHHHHHH. So CH3, CH2, CH2, CH3. You can also write it like this. This is called the condensed formula. Okay, that is butane. Now, I'm not showing hydrogen. Right now, I will not be showing hydrogen, just to explain the basic concept of isomerism. Let's say I have butane. Butane has 4 carbon atoms. Okay. In fact, I'm going to show hydrogens. You might get confused. Now, this is the formula. This is the structural formula of a butane molecule. Okay. Now, let's say I draw it like this. Let's say I draw it like this. These bonds, these dashes means hydrogens. Hydrogen, 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 there's another hydrogen, there's another hydrogen, and I can draw the same structure like this as well. H, 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 and H. Okay, and I can also draw it like this. H, let's say. Now, if you look at them, it may seem that all of the structures are different. You can easily deduce from it that all the structures are the same. They have the same molecular formula. All of them have the molecular formula C4H8, but their structure seems different. So they must be isomers of each other. But that's not the case. There is more to what meets the eye here. You'll be very careful here. See, the thing is, if you look here, this structure is actually the same like this. It's just that instead of writing carbon at the front, I wrote the carbon at the bottom. So I can actually twist the structure up and it will return to its original form. So this is not an isomer. Isomer are two distinct molecules with two different structures. Okay. Similar is the case with this. You can just twist this here and it will go back to this formula. But if you see this is different. This is completely different. You cannot twist it to make original molecule. It means that they both are isomers of each other. This is called normal butane. This is called crazy butane. Just kidding. From crazy butane, it is called isobutane. Isobutane. Okay, so they both are going to be isomers. So how do you make isomers? Here we primarily are discussing chain isomers. Okay, in A levels you are going to study a lot of other isomers. Just remember that these are chain isomers in which we change the length. We change the length of the chain. We change the length of the main chain. Okay, I picked up this carbon group and I attached it to one of these. I cannot attach it here or here, because if we attach it here, it's already attached over here, and if I attach it here, it's going to make the same structure. I can only attach this carbon group here. Okay, let's talk about pentane. So pentane has 5 carbon atoms. Now let's say if I want to make the structural isomers of pentane, I picked up this carbon. I cannot attach it over here. If I attach it, because it's already attached there, it's going to make the same molecule, and I cannot attach it on the last molecule because it will form the same compound again. So remember that you cannot, whenever you're making chain isomers, whenever you're making isomers, you are not going to attach the carbon chain to terminal carbons. Terminal means starting or ending carbons, because they're going to make same structures. So you can attach this carbon either here or here. Okay, it can be, so its isomers can be this or this. I've not written hydrogen here. I will, in the hope ke aap khud kar loge. Okay, even these two are the same. If you just flip it like this way, if you flip it, this will be formed. So even this is not an isomer. Okay, so these are going to be chain isomers of pentane. Okay, and you can also make another one. For example, in this case I picked up only one carbon. Let's say this time I picked up two carbons. I can arrange them like something like this. This is also an isomer. It has the same molecular formula but different structural formula, because this particular molecule cannot be twisted back into this. So this is going to be an isomer, and this is going to be an isomer, and this is going to be an isomer. Remember, original molecule is also an isomer, right? Okay, so there are three isomers, in fact more precisely three chain isomers of pentane. Okay, so that's how you make isomers. Now, I talked about cracking at the start, but I don't think we should be doing cracking right now. We should do cracking in alkenes as their reaction, okay? But before that, we are going to discuss some past papers related to alkanes. This statement about alkanes is correct. Ethane reacts with chlorine in an addition reaction. No, it reacts with chlorine in a substitution reaction, because ethane is an alkane. Propane has a higher boiling point than butane. Yes, no, because butane is C4H10. It has 4 carbon atoms, and propane is C3H8, 3 carbon atoms. Butane is a bigger molecule, so it's going to have a higher boiling point. So it is wrong as well. The molecule of the alkane that contains 99 carbon atoms will have 200 hydrogen atoms. That is true, because the general formula of alkane is CnH2n plus 2. So if there are 99 carbon atoms, so hydrogen atoms are going to be 200. 99 multiplied by 2 plus 2 will be 200. Okay, that's true. There are 3 isomers with the formula C4H10. No, butane only has 2 isomers. One is normal butane and the other one is this butane. It's also called 2-methyl propane. Okay. What is the correct definition of isomers? Compounds with the same molecular formula but different structures. Okay. This statement about the properties of propane and hexane is correct. Propane has a higher boiling point than hexane. That's not true. Hexane has a higher boiling point. It's a 6 carbon atom. It has 3 carbon atoms. Propane has relative molecular mass. No, does not have a higher relative mass. Propane is more flammable than hexane. That's true. Lighter compounds catch fire quicker as compared to heavier hydrocarbons. This statement about the properties of a propane and hexane is correct. That is the same question. Moving on. Which alkane, when one hydrogen atom is substituted by chlorine atom, will not produce isomers? Okay, I replaced this by chlorine atom, I replaced this by chlorine atom. He said which alkane, when one hydrogen atom is substituted by chlorine atom. I replaced this by chlorine, I replaced this by chlorine, I replaced this by chlorine. We already know that they are going to form isomers. The butane do form isomers. Okay, since you have replaced chlorine, okay, we particularly studied chain isomers. There is another kind of isomers. They are called position isomers. Position isomers are those isomers in which the functional group position changes, in which you change the functional group of a homologous series. For example, when you replace hydrogen with chlorine, it becomes halogenoalkane, which is another homologous series. You're not required to know a lot of stuff about it. Just remember that when you replace hydrogen with chlorine, that is another compound that is called halogenoalkane. They are separate homologous series. Okay, which is nothing but just hydrogens are replaced by chlorines. So what are position isomers? You change the position of functional groups. Like in this case, chlorine's position can be shifted. Like you have many options to replace. You can put chlorine over here, it will form a different molecule. You will put chlorine here or here, it will form a different molecule. You can put chlorine over here, it will form a different molecule. But with this, Even if you put chlorine on this carbon atom, is actually going to be the same because they just have two carbons. Okay, the positions are not going to matter over here. So A will not form any isomers. Okay. A mixture of four gases, methane, ethane, propane, butane, is cooled until the first drop of liquid is formed. Which compound is most likely to be present in this drop? Okay, you have four gases. Butane being the heaviest, which means it will have the highest BP. It will have the highest boiling point. So when you started cooling it, obviously butane is going to be the one which is going to condense first. For example, let's say 10, 20, 30, just assuming 40. This was the boiling point of methane, this was ethane, this was propane, this was butane. Okay, now you started cooling it. At 40 degrees Celsius, butane was boiled. So obviously 40 degrees Celsius is going to be achieved first when you start cooling it. So butane is going to be cooled, butane is going to be condensed first. Okay, the thing that is boiled first is condensed last. The thing that is boiled last is going to condense first. And so butane would be the answer here. Okay, which statement about alkanes is correct? Their boiling points increase as the length of carbon chain increases. That's true. That's true. That's true. You don't need to see any other option. The diagram shows four structures. Which structures are isomeric butenes? Okay, you can do this after you have done butenes. So, which molecular formula and boiling point could be correct for another alkane? Methane, the first member of the alkane homologous series, has a boiling point of minus 161. Which molecular formula and boiling point could be correct for another alkane? If the first member of alkane has a boiling point of minus 161 degrees Celsius, it means that rest of all the alkanes will have boiling point less than minus 161. Okay, because methane is the first member. So all of the rest of the members obviously will have bigger structures and higher boiling points. So this is not alkane because C2H6 is an alkane, not C2H4. So either answer could be this or answer could be this, because even C is not an alkane, because alkane की पहचान ये होती है कि number of hydrogen atom is twice the carbon atoms plus 2. Okay, so this is not the case with C. You're left with B and D. Minus 185 cannot be the boiling point of ethane, because ethane has higher boiling point as compared to methane, so it has to be D. Okay, ethane cannot be the answer because boiling point of methane is minus 161, so boiling point of ethane has to be lower than minus 161 because it's bigger. Remember that negative value, smaller the negative value, if you're going downstairs, if you're going down, like if you're going to minus 150, it means that the boiling point have increased. Okay, so for ethane, the boiling point must be less than minus 161. So answer would be D, minus 42. This fits. Okay. Member of a homologous series have a general formula. State one as the characteristic of homologous series. They have same chemical properties. They have same chemical properties. Deduce the general formula for the cyclopropane homologous series. So these are the cyclopropanes shown. Its molecular formula is C3H6. Its molecular formula is C4H8. So its general formula is CnH2n. Because hydrogen atoms are twice the number of carbon atoms. So you can write CnH2n. Okay. Cyclopropanes react in a similar way to alkanes such as methane. Write the chemical equation for complete combustion of D. So D ka molecular formula is C3H6. Yes, C3H6. So C3H6 will react with oxygen to form carbon dioxide and water. Okay, you have to balance this equation. Carbon 3, hydrogen 3, that multiply kar denge. There are 6 plus 3, 9 oxygens on the right hand side, so multiplied by 9 over 2. Name and draw the structure of an alkene that is an isomer of compound D. I think we are going to do it once we have done alkenes. But yes, we can only do it if we have done alkenes. Moving on to another question. What is the general formula of alkenes? CnH2n plus 2. What are the draw the two structures of two isomers of C4H10? So that would be of normal butane and that would be of isobutane. Just draw the just mention the hydrogens as well. It's very tedious to do, yeah. It's very tedious to do. If you were in A levels, I would have just drawn skeletal formula. That would have been easier. Anyway, that's how it is. Hydrogen, hydrogen, hydrogen. Just count carefully. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So, one of the isomers of C4H10 butane reacts with chlorine in the presence of ultraviolet light. It forms hydrogen chloride gas and a mixture of liquid compounds. Name this type of reaction. So this is called a substitution reaction. Whenever alkane reacts with chlorine or any other halogen, that the reaction is called substitution. Draw the structure of one of the liquid compounds. We know that whenever you can just write HCl, that would be fine as well. Or you can also so you're going to draw the structure. So C4H10, the first reaction would be, it will react with chlorine and one hydrogen will be replaced with chlorine. So you can draw the structure of this and HCl will be released. HCl is a gas here. HCl is not aqueous, so you cannot draw it. Okay, they are asking you to draw one of the liquid compounds. So C4H9Cl, C4H9, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2. Just add Cl over here. किसी भी कार्बन पे Cl लगा दो बस. मैंने लगा दी. So that would be the structure. Name the process by which butane is separated from crude oil. That is called fractional distillation. Fractional distillation. Okay. Explain how fractional distillation separates petroleum into different fractions. We did this when we did separation techniques. If you don't know, you can go back to the previous video. Explain the meaning of the term homologous series. Members of homologous series have the members of a homologous series have same molecular formula. Have same general formula. Have same general formula. They have same functional group. And they have, you can also write about the physical properties. So it's a 2-mark question, so 2 properties are enough. Again, they're asking you to draw the 2 isomers of butane. I hope you can make it. Construct an equation for the complete combustion of hexane. So C6H14, any compound, whenever you have to write the equation for complete combustion, just react that compound with oxygen and carbon dioxide and water is formed. Okay, carbon 6 on the left, 6 on the right, hydrogen 14 on the left, I made it 14 on the right. Oxygen became 6 to the 12 plus 7, 19, so it will be 19 over 2. If you don't want fractions over here, multiply the whole equation by 2. This fraction will be removed. This will become 12. This will become 14. Your call. Okay, so that's all from this chapter. In my next video, I'll be talking about another homologous series called alkenes. Until then, stay tuned. Allah Hafiz.